There we go. It's okay, you wouldn't have been able to see my like antics up here anyway. The stock solution, and that is a concentrated solution. In this case, we have 1.0 molar CuCl2. How much of this do I need to give me that? What volume of 1 molar CuCl2 do I need to give 0.01 moles of CuCl2? I'll turn down the lights a little bit so you can see a little bit better. Now, it's been a little bit of while since we've done this, so I'm going to remind you that you should always rewrite molar as moles per liter. Yeah. You don't know? You think you know. What would you do? So you'd go 0.01 moles. What would you multiply by? Sorry? Liters over moles. Look at this, we've now got some unit cancellation going on. How beautiful is that? Because we wanted the volume. Now, what numbers are we going to use in here? 1 mole, right, per 1 liter. Oh, and so this is a really boring question. We just get 0.01 liters, which you normally wouldn't write it like that. Normally you'd write it as milliliters because you're going to measure it like in a container that gives milliliters. So that would become 10 milliliters. I'm playing fast and loose with my sig figs here. Okay, I'm just ignoring them completely. Okay, so that's what we're doing today. We are taking a stock solution and we are diluting it. Can you see how much more dilute this is? We're actually diluting it 1 part in 10 to give us a 0.1 molar solution, right? Because this is 1/10 is concentrated. So we had to take 1 part stock solution and 9 parts water to give us 1/10 of the volume, okay? So let's take a look at the little pictures that we've drawn here, okay? So remember, when you're diluting something, the moles always stay the same. So you will be given the volume and the concentration of the diluted solution. So for the diluted solution, you will be given the molarity and the volume. And if you are given molarity and volume, what can you find? You can find moles. Now, you know that the moles in the dilute solution are equal to the moles from the stock solution. Like whatever volume of the stock solution has to contain the same number of moles. Is this going to be a bigger volume or a smaller volume? It's going to be a smaller volume because we have a more concentrated solution. So you're going to now have to figure out the volume of the stock solution that contains that many moles, and you'll do that using the math that we just did, using molarity as a conversion factor. Okay? So let's take a look at a little pictorial representation. We want to make 2 liters of little dots at a concentration of 2 moles per liter by diluting a stock solution of 8 molar. So we have the more concentrated stock solution, okay, and then we have our new diluted solution. So here's our stock solution, or no, actually this is our diluted solution. This is how much we need. We want to have 2 liters. So here we have 1 liter and 2 liters. And we want each of those liters to contain 2 moles. Is good? Okay, so 1, 2, 3, 4, you can see we have 4 moles. You can do the math for that. 2 liters times 2 moles per liter gives us 4 moles. And now we say how much of the 8 molar stock solution, so here is 1 liter of the 8 molar stock solution. You can see we got 1, 2, 3, 4, 5, 6, 7, 8 molecules in there, or moles rather. How much of that do we need to give us 4 moles? Well, we could cut this in half, and so a half a liter would contain 4 moles. We're not going to draw out these pictures every time, so wouldn't it be nice to just calculate it and say, I want 4 moles, how much volume do I need to get that? Make sure that your moles cancel with your moles, and you'll have liters on the top, so you're just flipping the concentration, okay? So here is a procedure for making a diluted solution, and I think probably we won't get to this today, but tomorrow I will give you a chance to actually do this. Oh no, I'm not tomorrow because you're writing your test tomorrow. I'll give you an opportunity on Thursday to actually do this, okay? So you will take whatever volume you need of the stock solution, okay, you measure it out, and then you transfer it into the new volumetric flask. Yes? So here's our stock, and we move it and we put it into the new volumetric flask. And then we add extra water up to the mark. And then what would we do? You would still have to stopper it and flippy flippy. Don't flip like this though. Don't be like a pizza maker, okay? Just hold both ends and flip it, okay? When you get very close to the final volume, you will use a wash bottle or an eyedropper. Okay. Volumetric flask should then be stoppered and inverted, turned upside down to ensure thorough mixing. Now, I don't know how important this is going to be for you this year or next year. Usually we give you the concentrations of the acids that you need, but when you are diluting an acid, it can actually be quite exothermic. The addition of water to an acid is quite exothermic. So when diluting an acid, you won't put the acid in first, you will put the water in first so that you have a lot of heat. Water has a high heat capacity. It is able to absorb all that extra energy. So if you have a lot of water there first, even if it's exothermic, the water will heat up, but it won't actually boil, okay? So you're going to do as you oughter, as you ought to. Do as you oughter, add acid to water. And if that wasn't fun enough, we have a little cartoon of somebody adding the water to the acid and blowing up the lab. Okay. And then, did I manage to put it in here? Oh, I did not. Oh, I have a really cute little picture of an otter holding a flask with little goggles on, and I can't believe it's not here. I'm so sad. I'll make sure I find a copy for you at some point. It was really, really cute. Anywho, why don't you try some of these questions? Maybe like numbers 1 and 2. We're doing these 2 questions. We're doing a couple questions here. Give them a try. You can just go straight to the answer. You can be like, yeah, why not? Sometimes you need hard work and you need time. You know what I mean? Yeah. Exactly. It's a little short term very first.
Oh, wait, you need 0. All right, right, right. 0.00.
I mean, right? So you have to go long height, start with yours. Start is putting out no. Sam, grade 12. Tyler says goodbye. Sorry, grade 12. So we have to go to Mr. Holder, who has lovely videos.
How will we know the volume of the stocks?
But he's good, like his materials are good. I'm okay with this like weird one.
If I were a betting, all your things. I have nothing else happening. I have allotted a 1 hour nap. So 1 hour after. Yeah, what did you know last year?
Why are you making him read the Why are you asking me words? What's up?
We have 15 minutes left, and because this course is relentless and never stops, I know, I hate me too. Oh, okay. Okay. All right, here we go. We are on page 42. Page 42. So you are going to need to find the moles of, you're going to be given a solution. This is going to be solution A. Yes. 300 milliliters of 0.250 molar NaCl. You're going to be given another solution, 500 milliliters of 0.100 molar NaCl. That would be solution B. Now, if you mix the two of them, what is the resulting concentration of NaCl in the mixture? Could you find moles here? Yes, you could find moles. So we'll call that moles A, okay? Could you find moles here? Yes, you could call that moles B. What's the total number of moles once you're done? Moles A plus moles B. And then you just divide by your total final volume. So you find moles in A, you find moles in B, you add the two together and you divide by the total volume. It's pretty straightforward. But let's just work through the little problem here. So we have solution A. I'm going to color it yellow. So the moles of NaCl in A, we have 3.3 liters times 0.250 moles per liter. And the liters cancel out. And we end up with moles. So that's A. For B, we have 0.5 liters, which is 500 milliliters, of, remember of means times, of 0.100 moles per liter. And that gives us a total of 0.500 moles of NaCl. So that is moles B. Now, I don't know what I've done with this because I think I was working in millimoles. So let's just cross this out, okay? Or you could say millimoles, millimoles, millimoles. But really what we should be saying is we should be saying 0.0750 moles plus 0.0500 moles is equal to 0.1250 moles of NaCl. That's our total moles of NaCl. Is good? Is good. Okay. Then you take your total moles and you divide by, you say, what's my total volume? Well, I have 0.3 liters and 0.5 liters is 0.800 liters. And you just do the division and there's your molarity. Do you need another example or do you want to just be like done with this? Yes. Only one solution? That would be just like the regular dilutions. If you're just adding water. Oh, you're given the final. You could do that. It's trickier, but you could. Yeah. So you would have to do some thinking about what you would do there. Okay. So there's some exercises here. You could try these. And then your homework is just to study for your test. Okay?